Hi students, welcome to physics classes. Today we will discuss about study of motion through graphs. Here we will discuss various graphs and how to draw the graphs. Graphs of motion. Study of motion through various graphs. Now, if information about various quantities, various physical quantities related to motion, information about different quantities related to motion is given in tabular form. Tabular form for different instances of time. Then it can be converted into graphical form. Tabular form to graphical form. It make easier to find out the relation between the physical quantities. If any information given in the form of tables, tabular form, that can be converted into graphical form. So we can easily find out the relation between them. Now we have different types of graphs. That first one is distance time graph. Distance time graph. In a distance time graph, distance is taken on y-axis and the time is taken on x-axis. Now, distance is taken on y-axis, time is taken on x-axis. Now, for example, we will take a table of form, distance, time. For example, if a bus traveling on the road, it covers different distances in different intervals of time. Let us take distance in meters, time in seconds. For example, 0, 1, 2, 3, 4, 5 seconds. It travel 0 seconds, 0 meters. First second, 2 meters. Second second, 4. Third second, 6, 8, 10, like that it travel, for example. Now that can be represented in the graph. Now see, on x-axis, time we are taking 0, 1, 2, 3, 4, 5. Scale. Time on x-axis 1 equal to 1, y-axis 1 equal to 2. So for 0 second, it travel 0 meters. First second, 2 meters. Second second, 4. Third second, 6. 4, 8. 5, 10. Now if you join this, we got straight line passing through origin. Now here, by using this graph, we can find the speed of the bus. By using this graph, we can able to find the speed of the bus. Now generally, what is the definition for speed? Speed equal to distance traveled by time taken. Speed equal to distance traveled by time taken. Now here we can find the speed of the bus. For example, what is the speed of bus between second second to third second? Between second second to third second. Now here at the second second and the third second, distance traveled from 4 to 6. Distance from 4 meters to 6 meters. Okay, now here let us take this is T1, this is T2, this is S1, this is S2. Now the speed equal to change in distance S2 minus S1 by T2 minus T1. Change in time is T2 minus T1. Now how much it is? 6 minus 4 by 3 minus 2, 2 by 1, that is equal to 2 meters per second. Okay, here sometimes distance they can give you x1, x2. So formula x2 minus x1 by t2 minus t1 also we can take. Distance can be denoted with either x or s, no problem. Now finally this can be written as, finally it can be written as change in distance by change in time taken, delta x by delta t. It can be written as delta x by delta t, change in distance by change in time taken. Now this delta x by delta t called the slope of distance time graph. Slope of distance time graph gives the speed of the object. Speed of the object. Slope of distance time graph gives speed of the object. Now we can see different examples, different situations, how the graph is. Now if a graph is given like this, distance time graph, time, distance, given like this. Now if the graph is parallel to time axis, if the graph is straight line parallel to time axis, so here in y-axis there is no change, but in x-axis change is there. That indicates as time is going, distance of the body not changes. So we can say this graph indicates body is at rest. Okay, now in previously we seen one graph as time increasing, distance also increases. Now graph is a straight line passing through origin. Graph is a straight line passing through origin. Then we can say it is uniform speed. It is uniform speed. Now if graph is a curved, graph is curved, not straight line, then graph is non-uniform speed. Non-uniform speed. Now slope of the distance time graph when graph is parallel to time axis indicates body is at rest. Slope of distance time graph when graph is straight line passing through origin, then graph is indicates uniform speed. Slope of distance time graph when graph is curved indicates non-uniform speed. Next one is displacement time graph. Now in displacement time graph, displacement is taken on y-axis and the time is taken on x-axis. Now as we see in distance time graph, displacement time graph also same. Now in the distance time graph, whatever we got speed. Now in displacement time graph, slope of displacement time graph, we will get velocity. If graph is straight line parallel to the time axis of displacement time indicates rest. Passing through origin, displacement time graph, uniform velocity. Curve, displacement time graph indicates non-uniform velocity. The only difference here in the displacement time graph we can find displacement is negative sometimes. Displacement can be zero. Displacement can be positive. All we can find. Negative graph also we can find. As we have negative x-axis, negative y-axis. That also we can find. But in the distance time graph, we won't find negative because distance is either 0 or positive. That is only the difference in displacement time graph, remaining everything same. Now next one, velocity time graph. Velocity time graph. Now as we seen previously, distance time graph, displacement time graph, always we are indicating time on x-axis. Now here also time is taken on x-axis, velocity is taken on y-axis. Now here slope of velocity time graph gives acceleration, means change in y-axis. Slope means change in y-axis by change in x-axis. Change in y-axis means change in velocity, change in x-axis means change in time. That gives us acceleration. Now we'll see different graphs. For example, if a graph is given like this, velocity, time. If a graph is parallel to time axis, in the displacement time or distance time, if we got like this, we thought it is rest. But here velocity time graph, it indicates no change in the velocity. As time increases, no change in the velocity. That says uniform velocity. So when uniform velocity, acceleration is 0. Suppose if a graph is given like this. Now suppose a graph is given like this. Graph is straight line passing through origin. As velocity continuously increases, time also increases. When the time is increasing, velocity also increasing. That indicates uniform acceleration. Now as velocity increases, it can be positive acceleration. Now we'll take another case. Velocity time graph, velocity of the body continuously decreases with time. It is taken as retardation. Velocity time graph is decreasing with time. Velocity decreasing with time. It is a retardation or negative acceleration or deceleration. Now here we will see how to find acceleration. Now on x-axis I am taking time, on y-axis I am taking velocity. Now if a graph is given like this, now on x-axis we can take time 0, 1, 2, 3, 4 seconds. Time in seconds. On y-axis 4 meters per second, velocity in meter per second. Next 8, next 12. Like that we have taken. Okay, on here each one is changing 4, 8, 12 like that. Now if they asked what is the acceleration between 2 to 3 seconds, now this is at 2 and this is at 3. Now this is the velocity, now slope equal to change in y-axis by change in x-axis. So slope of velocity time graph gives acceleration. Then acceleration equal to what is the change in y-axis? 12 minus 8. Change in x-axis 3 minus 2 equal to 4 by 1, 4 meter per second square is the acceleration. Now here velocity time graph, slope giving acceleration. Now area under velocity time graph gives displacement. Now for example a graph is given like this. Now what is the displacement of the body between 2 to 4 seconds? 2 to 4 seconds, what is the displacement? Now here we should find area. Now 2 to 4, this is at 2, this is at 4. Now it is uniform velocity. Body is moving on with the uniform velocity. Now area means it is looking like a rectangle. This is one side, this is another side. Now rectangle area formula, length into breadth. Now between 2 and 4, how much is there? 2. And 0 to 8 equal to 16 meters is the displacement. Thank you for watching. Please subscribe for more updates.